Okay, the first thing I wanted to do in this video is thank those people who have been asking for help. So thank you, Leah, for reaching out and asking for a bit of extra support, and for your questions today in class, Bluey and Hayden. It's really difficult for me to work out how to help you folks during remote learning unless somebody sort of speaks up and says, I'm sort of stuck on this, can you do an extra video, or can you give me an extra example? So I really appreciate those people who are asking for help. It shows that you're engaging in the learning process. So what I was going to look at today is exercise 14E, and I'm not going to write down or photograph all of the questions, so you will have to check them from your textbook. But the first question I want to do, and I'll get my pen a little bit thinner than that, is just question 1A. Let's go right from the beginning. And the basic information in 1A tells me that sine theta equals 0.42, and it wants me to find what is sine of pi plus theta. Okay, so what I've got to do here is think about, well, what am I actually doing? What does this sine theta 0.42 actually mean? Where is sine theta, where is sine of pi plus theta in the unit circle? And we want to break it down into a couple of those key points. So the first thing I'm going to do is I'm going to use the unit circle to just have a look at where is sine theta equal to 0.42. So before we do anything, let's just have a little bit of a look. Where is sine theta equals 0.42? So what we have to remember to do that is that it is telling me that sine is 0.42. So remember that sine's on the y-axis, or the y value. So if up at this point it is 1, then that point's about 0.5. So 0.42 would probably be about here. So this sine theta equals 0.42, that is just a length on the y-axis. Okay, it's a length on the y-axis. So the angle has to be about there. So the height on the y-axis is equal to 0.42, or the height on the y-axis, the vertical height, is 0.42. And this is my theta. Okay, so we've got that so far. Now if we duplicate that and we start looking next at this sine pi plus theta. Okay, so where is sine pi plus theta? Well, I know that 180 degrees is equal to pi. So if we added that same theta amount to pi, this angle here would be pi plus theta. Now what can you tell me in relation to this 0.42? Well, if I look at it closely, I can assume that that length, because of symmetry, is going to be the same as that length. The only difference is that I'm now on the negative y-axis. So if I'm on the negative y-axis, the sine value would be negative 0.42. That length has gone down 0.42 instead of up 0.42. So what does that all mean? Well, it means that if sine theta equals 0.42, then sine of pi plus theta will equal negative 0.42. So don't forget, think about those lengths. This is really important. Sine and cos are just lengths in the unit circle, and theta plus pi, or pi plus theta, or 2 pi minus theta, they are also just angles. They lie somewhere in the unit circle. And all of these angles are going to be similar by symmetry. Okay, so they're going to be linked somehow, and we've got to think about that connection. So So let's have a look at another question like that. The second question, let's have a look at, let's do cos of 2 pi minus x. So part H, question 1H. Now the question, again, not writing out the whole question, the short version is that cos x equals 0.7, and they want me to find cos of 2 pi minus x. Okay, let's start with the cos x equals 0.7. So let's start with, oops, I don't know why I left out the cos there. Let's start with that part. How am I going to work out that? Well, I'm going to use my unit circle and I'm going to think about what's actually going on here. Beautiful circle. I might move that across a little bit so it's actually in the center. Okay, so cos. Cos is my x value, and I want my x value to be 0.7. So we want the x value to be 0.7. So let's have a think about that. If this is 1, that's roughly 0.5. So this horizontal distance, 0.7, would be about there. Hopefully you agree. So that distance is about 0.7. Okay, so the horizontal distance for my angle has to be 0.7. If I go up to where I hit the unit circle, I'm just going to rub that out because it's in a really bad spot. Here's my angle, theta, where the cos value, or the horizontal length, again, rub out some of these extra values because they're just in the way. My horizontal length equals 0.7. Cool. So now let's work out where is 2 pi minus x. Now I just realised I made a mistake. I wrote theta, but my angle is actually x here. Don't confuse the angle x with the x-axis. It's a bit annoying how they do that, but it is what it is. We're going to work with it. Alright, so now where is 2 pi minus x? Well, we know that a full loop around the unit circle equals 2 pi. And then if I do 2 pi minus x, 2 pi minus x, that means go backwards. Oops, go backwards. X degrees or x radians, it doesn't matter if it's degrees or radians. Go backwards x degrees from 2 pi. I should say radians actually, because 2 pi is in radians, so let's assume that it's radians. Go backwards x radians from 2 pi. So if I'm going to go backwards, I need to go all the way around to 2 pi, and then I need to come backwards the same angle as in that first quadrant, x. So I need to come backwards a symmetrical amount that is also, again I'll put that 0.7 in a bad spot again, that is also x. So we're using that symmetry amount here. Okay, so I want to find the cos value. I want to find out this distance. Because it's cos, I'm finding the horizontal distance for 2 pi minus x. Finding the horizontal distance for the angle all the way around to here, which is 2 pi minus x. I know I'm repeating myself, just want to really drum that in. Now I can see the horizontal distance is exactly the same as the horizontal distance that I started with. So what does that mean? That means that cos of 2 pi minus x is exactly the same spot as cos of x, which means it also equals 0.7. And that's the end of the question. Okay, let's jump now and we'll have a look at question 2. I want to do question 2C. 2C says if cos x equals cos of pi on 6 and x is greater than or equal to 3 pi on 2, and actually it's not equal to, it's just greater than 3 pi on 2 and less than 2 pi, find the value of x. Find x. Okay, first hint here. Please recognise we have two parts that are equal to each other but are not the same. They are equal but not the same. So if they're equal, it means they have to have the same value. But this angle, theta, which is pi on 6, will not be the same as this, oops, that's the wrong tool, will not be the same as this theta, which is x. Alright, so let's work this out. Let's start thinking about this in a little bit more detail. They also tell me over here that x is between 3 pi on 2 and 2 pi. So let's work out, well, where is 3 pi on 2 and where is 2 pi? Again, these are angles. Alright, x is an angle, so it's an angle. So we want the angle in the unit circle has to be between 3 pi on 2 and 2 pi. Here's my circle. Just for the record, I'm not just drawing these circles for the demonstration. When I'm doing these problems, I always draw a unit circle to help me understand what's going on. I know that a full lap of the unit circle is 2 pi, and hopefully you know that 3 pi on 2, this is 1 pi on 2, this is 2 pi's on 2, which we usually just say is pi, and this down here is 3 pi on 2. So it's telling me that my x value is somewhere in this quadrant. Now I'm not happy with that highlighting, let's make that a little bit smaller. My x value has to be somewhere in this quadrant because it's got to be between those two numbers, 3 pi on 2 and 2 pi, or between those two angles. So I'm somewhere in here. My x value is in here. Let me write that down. My x value is in here. And it is the same as cos of pi on 6. Alright, so now let's put cos of pi on 6 in there. So we've got to know radians. Well, pi on 6, hopefully you just remember that pi on 6 is 30 degrees. If you don't know that pi on 6 is 30 degrees yet, try and memorise that because it's going to help you a lot. So this is pi on 6. So my cos value of pi on 6, my cos value is the horizontal length. So this is my cos value of pi on 6. And x is exactly the same as that, just in this third quadrant. So here is the angle that will be the same as cos of pi on 6. So this is my angle, which is pi on 6. I want to find out the value for x, which is this angle all the way around to here. How can I do that? Well, x will be the same as going all the way around to 2 pi, and then coming back pi on 6. Because of symmetry, I know that that little angle in here, because of symmetry, this also has to be pi on 6. So if I want to find out what x is, I shouldn't say degrees, it's radians. If I want to find what x is, I'm going to go all the way around to 2 pi and then come back pi on 6. So my x value is all the way around to 2 pi and then come back or subtract pi on 6. Now get a common denominator. 12 pi on 6 minus 1 pi on 6, which equals 11 pi's on 6. So my x value is 11 pi on 6. Okay, so in all of these problems we looked at the length of sine or cos, and we looked at the angles, and I put those two pieces of information together to solve the problem. Okay, we're using symmetry along the way. Now there's other examples in this question that will try and trick you, but I'm going to have a look at exercise 14F, which uses some of the same skills just in a different way. So exercise 14F, and it uses exact values as well. Alright, so let's do a quick breakout of the exact values table. This is how I remember it. So the first thing I do is I set up my table and I have my angle, and I'll do degrees as well, and then we'll do radians, and then next I'm going to do sine, and then I'm going to do cos, and then I'm going to do tan. Alright, so really quick table, exact values, you have to memorise this. The key angles are 0 degrees, 30 degrees, 45 degrees, 60 degrees and 90 degrees. And if we write them in radians, they are 0 radians, pi on 6 radians, pi on 4 radians, pi on 3 radians, and pi on 2 radians. They are the key angles in my exact values table. And then sine goes root 0 on 2, then root 1 on 2, root 2 on 2, root 3 on 2, root 4 on 2. And then cos is the complement of sine, so it goes in the opposite direction. So it is root 0 on 2, root 1 on 2, root 2 on 2, root 3 on 2, root 4 on 2. And tan is sine divided by cos, and if sine is, hang on, let's work out what sine is. Root 0 on 2 is just 0. Root 1 is 1, divided by 2 is just 1/2. Root 2 on 2 is exactly the same, but I can also write that as 1 on root 2. Root 3 on 2 can't be simplified, and the square root of 4 is 2. 2 divided by 2 is 1. So the opposite here, 0, 1/2. Root 2 on 2 can also be written as 1 on root 2. And root 3 on 2 doesn't simplify, and root 4 on 2 is equal to 1. So if tan is sine divided by cos, 0 divided by 1 is 0. Root 2 on 2 divided by root 2 on 2 is 1, because they're exactly the same, so that's the easiest one. And then 1 divided by 0, you can't divide by 0, so that's undefined. And then finally from here, if I do root 3 on 2 divided by 1 on 2, that actually just becomes root 3. And if I do 1 on 2 divided by root 3 on 2, that becomes 1 divided by root 3, which is also root 3 on 3. You have to memorise this table, and with a bit of practice you'll see some patterns, and it won't take you long to memorise it. But we need to know those values. So now let's have a look at question 2. Let's do 2D. 2D asks me to find sine of 7 pi on 6. So we have pi on 6s and we have sines. So using my exact values table, it's going to have something to do with this. Alright, always. Because my denominator's 6, my denominator's 6. They link, not coincidence. So let's work out where is 7 pi on 6. Alright, so what is 7 divided by 6? 7 divided by 6 equals 1 with a remainder of 1. Or I could say it is 1 whole plus 1/6. Okay, now that fraction skill there is really useful for working out where is 7 pi on 6. Because what I'm going to do here is I'm going to say that sine of 7 pi on 6 is exactly the same as sine of 1 pi plus 1 more pi on 6. Now that links directly to what I did here. I just added the pi's. So if I go to my unit circle, I'm getting a little bit better at drawing these slowly. Here on the left hand side on the x-axis is pi. Here is pi on 6, it's 30 degrees, so roughly there. So if I go around, let's change colours, let's go around to pi, and then we add 1 pi on 6, then this angle all the way around here would be pi plus pi on 6, which will be the same as 7 pi on 6. So hopefully that makes sense and we can work out where 7 pi on 6 is. Alright, that's in my way, let's rub that out, not the circle part, just my equals, get rid of that. Bit of space here. Alright, so this here is my angle pi plus pi on 6. And what we've been asked to work out is what is 7 pi on 6, or sine of 7 pi on 6. And what we've been doing is we've been looking at these values as coordinates, where the first value is the cos coordinate and the second value is the sine coordinate. And in this particular case, if it is cos of pi on 6, sine of pi on 6, I can actually look that up in my exact values table above, and I can see that cos of pi on 6 is root 3 on 2, sine of pi on 6 is a half, and I can say that this point here has the coordinate of root 3 on 2 and 1/2. Okay, so what's that got to do with my question, sine of 7 pi on 6? Alright, well, this length here will be exactly the same as this length here because of symmetry. And this length here will be exactly the same as this length here because of symmetry. The only difference is this point, it is on the negative x-axis, so it would be negative root 3 on 2, and it is on the negative sine axis, or the negative y-axis, so it would be negative 1/2. So my coordinates are very much the same, except the negatives and the positives change. Alright, so we can use that. We can say that sine of 7 pi on 6 is simply this value over here, the y-coordinate of that point. We can be a little bit clever as well, and we could say things like sine of 7 pi on 6 is equal to negative sine of pi on 6, which is equal to -1/2. I don't need to do that, but that sort of understanding and knowledge might help you into some future questions as well. What was the trick? Look for the reference angle in the exact values table. Work out where is it in the unit circle. And then finally, change colours. Finally, use symmetry and think about negatives. And they're my hints for doing those problems. And that will be the end of this video. Otherwise,